Hello, Triple. Just a little video about, we've got some questions to do on potable water, and then you've got some questions to do on life cycle assessments and recycling. I'm going to show you some of the potable water questions. First, remember that potable means safe to drink, it doesn't mean pure water. You need to know how to make potable water, and you also need to know how to treat wastewater. There is a required practical with potable water where you work out the quantity of dissolved solids, but this is not going to be assessed in these questions for homework. So in the UK, potable drinking water is produced from different sources of fresh water. Explain how potable water is produced from fresh water. So if I was to do this for 4 marks, I'm going to say where we get the water from. So I'm going to choose a source of fresh water, maybe a reservoir, or a lake, or a river, or a well, or something like that. So I would choose a place I'm going to get it from. So get water from a reservoir. Then I need to filter it. Filter through filter beds, if you remember. Filter through filter beds. I'm going to write that. Explain how. No, I think I'm going to say to remove solids. I'm going to describe it in detail. It's my exam, so I may as well give it a go. Filter through filter beds to remove solids. Then what do you do? Then sterilise. And I'm not writing it as a sentence here, so sterilise. There are 3 ways to sterilise. So I'm going to go using UV, chlorine, Cl2, or I could write chlorine, or ozone to kill microbes, maybe microbes or bacteria and viruses, something like that. But notice, I'm not just saying filter it, then sterilise it. I'm saying how we filter it, why we filter it, because they wanted me to explain, and you're really, really clever as a class. So you're going to go in and you're going to say why we're doing all of these things. So let's have a little look then. I've got here to find the marks. Here's the marking. Cool. So to get a level 2 response, 3 or 4 marks, let's have a little look. Relevant points identified, given in detail and logically linked to form a clear account. Choose an appropriate source of fresh water. Yes, ice, let's say river, ice, reservoir, which isn't on there, but it's a man-made lake. Pass it through filter beds to remove undissolved solids. Yay, to remove solids. Then I sterilised it. I mentioned all of those 3 to destroy microbes. So yeah, I must have remembered this question from previously. I'd have got 4. You don't need to hit all of these, but you do need to explain. Okay. A different country, so the first question about the UK, very little rainfall, but a long coastline, so next to the sea, and lots of energy, suggests one process this country could use. Now, I seem to remember this from last time. You can write desalination, but that isn't really a process as such. It is allowed, but one process. If you could name a type of desalination, even better. So reverse osmosis or distillation. Okay, I could say that. Okay, I can see the marks here from where I'm sitting. And it says, any one from distillation or reverse osmosis, allow desalination. Allow use of membranes. Don't like that. Wastewater is not fit to drink. Of course it's not. Treatment of wastewater produces 2 substances, liquid effluent and solid sewage sludge. Alright, draw 1 line from each substance to the way the substance is processed. Now it's sort of split over 2 things here. Effluent, aerobic. Yay, put it on there. Effluent is aerobic. Solid sewage sludge is anaerobic down here. Okay, anaerobic. So, sorry about the printing, not great. Okay, the table below shows information about the disposal of processed solid sewage sludge in the UK. This is going to be application of our knowledge. So in our notes, we've said that the solid sewage sludge is sold to farmers as fertiliser. But apparently not just that. In 1992, in millions of kilograms. So in 1992, 440 million kilograms is used as fertiliser, so that's gone up. So much more is used as fertiliser, much less is used as landfill, sent to landfill. Much more is burned. Other methods has gone down. Okay, so calculate the percentage of processed solid sewage sludge that was burned in 2010. The percentage that was burned in 2010. Calculate the percentage of processed solid sewage sludge that was burned. Okay, so this much was burned, and that was the total. 260 divided by 1413 times 100, give your answer to 3 sig figs. So an answer to loads of sig figs will get you 2 marks, 3 sig figs. Yeah, here's a little tip, right? Any answer to 3 sig figs. If you can't do the question and it says give it to 3 sig figs, just write a number. Do a sum. 10 plus 11, will that give me an equals 21.1. That isn't the answer, by the way. 3 sig figs. So if you're totally stumped, just give an answer for 3 sig figs. Anyway. Suggest one reason why the total mass of processed solid sewage sludge increased between 92. Why has the total amount gone up? Bigger population, right? Sure, that's the answer. It must be. Population increased. Yeah, is the main reason. Between 92 and 2010, the proportion of processed solid sewage sludge, I can't say, I'm just going to give up. I'm going to call it SSS. I'm just going to call it sludge, actually. Between 92 and 2010, the proportion of sludge used as fertilizer increased. Okay, so why do we need more sludge as fertilizer? Again, it might be that we've got, because of what I said, increased population, there's more food needed. You reckon? We'll give it a go in a minute. 2, selling it as more sustainable. Is that okay? So we stop sending it to landfill. Maybe we're running out of landfill space, so we're using more as fertilizer. I'm going to see some of these. Let's just have a look what they're after. All right, so increased demand for food. So we need, due to increasing population. Yeah, so I wrote that. Why do we need more fertilizer? Well, because there's more people, so we need more food. More sustainable, allow more sustainable, uses less energy. Landfill space is running out. Basically, if you know that landfill is bad, increased demand for organic fertilizer rather than chemical fertilizer. Okay, weird question, but not too bad. Over the back then. Water from a lake is used to water from a lake in the UK is used to produce drinking water. What are the 2 main steps used to treat water from lakes? Okay, step 1, filter, using filter beds. What was it that it says? Remove undissolved solids. That's what they liked last time. Remove solids or undissolved solids. Step 2, sterilize, kill microbes. Okay, kill microbes. Okay, they like microbes rather than bacteria, so they want microbes. Explain why it's more difficult to produce drinking water, just going to focus, from wastewater than from the water in lakes. Why is it difficult to produce drinking water from wastewater than from water in lakes? If you want to turn wastewater, like your poo and your wee, into drinking water, there's going to be a lot more steps, aren't there? So, there's going to be lots more steps to produce drinking water from this, including, what do we need to do? Well, we'd have to screen this first, then do I need to talk about all the processes to make wastewater? So hang on, water from lakes just needs filtering and sterilising. Water from wastewater would need to be screened. It would need bacteria to remove harmful matter, harmful microbes. Wastewater might also contain toxic chemicals that you'd have to remove. So basically, if you want to turn wastewater that contains wee, poo, shampoo, soap, all this stuff, it's going to take more process. So I think I'm going to go, it's going to take many more processes, and then I'm going to name some of those processes. That's not planned, that's kind of paper. Okay, here it is. Okay. Wastewater will need more processes. Okay, cool. So more processes because it contains more organic matter, more microbes, or toxic chemicals. I've possibly got that mark, haven't I? What did I say? Because you've got to remove harmful microbes. I did mention getting rid of shampoo. Okay, so right then, some countries make drinking water from seawater. Complete the figure below to show how you can distill salt solution to produce and collect pure water. Right, so this could be top of a conical flask. You could put some salty water in there. You would need heat underneath, and in here you could collect the pure water. Okay, so it's going to evaporate. It's going to go through that tube. It's going to go down there, and the pure water will come out in here, but you need to have the heat mentioned on there. How could the water be tested to show it is pure? You could check the boiling point and check that it was 100 degrees C. So consider the boiling point, 100 degrees C is pure water. Why is producing drinking water from seawater expensive? To desalinate seawater would require a lot of energy. So, lots of energy required. Okay, now the potable water questions. Life cycle assessments and recycling. So I'm 11 minutes in. Right, I'm not going through the calculations. You can do this. All right. I'm not going through this calculation. You can do that. 4 marks, 2 marks. So plenty of just normal calculations, mathematical skills. Right, I'm looking at this sort of stuff. This table below shows 3 methods used to dispose of wood and steel after use. So we're going to be evaluating the sustainability. So this is to do with life cycle assessments. It's the part of the life of a product where we either throw it away, we recycle it, or we burn it. Evaluate the sustainability and the disposal of wood and steel. So remember what evaluate means. It's firstly we're going to compare the sustainability and then we're going to reach a judgment. So I need to judge which of these is more sustainable. This is important that you do that. You have to do that. Okay then, so I'm going to look across both of these now and I'm going to talk about wood first. When wood is disposed of, 58% of it is disposed as waste, so it'll go to landfill. 36% is recycled and 6% is burned. Whereas steel has less that goes to waste, much more is recycled and none of it is burned. Alright, I'm going to now say what's good or bad about this. Burning wood will produce carbon dioxide, but because no steel is burned, carbon dioxide won't be produced because none of it is burned and it's not got any carbon in it. Recycling wood, so turning wooden products into other wooden products, saves energy and saves natural resources. You don't have to chop down new trees. Recycling steel means that you don't have to extract iron ore from the ground and you don't have to use a lot of energy. It takes less energy to recycle steel than it does to make steel from new. I'm just waffling here, and I'm going to look at the mark scheme in a minute. Throwing wood away or throwing steel away fills up landfill. So, what am I going to say then? So my judgment. So, it's bad. More wood is thrown into landfill, which is bad. So, steel wins the waste one. Steel, lots of steel is recycled, which saves on energy and raw materials. Only 36% of wood is recycled. And burning wood is bad in terms of global warming because a greenhouse gas is added. So my judgment is that steel is more sustainable. However, what else then? However, wood comes from a renewable resource. I've waffled there. I don't really know. I find these quite hard. Geographers are going to have an advantage on this. So let's see what sort of things it's after. All right then. A judgment. I need to make a judgment, strongly linked and logically supported. Right. So, indicative content, just reading from the table. Less steel than wood goes to waste. so less space is taken up in landfill. More steel is recycled, so less non-renewable resources are needed. No steel is burned, so no carbon dioxide is produced, so no contributing to climate change. I've mentioned all of these. Most wood are disposed of as waste, so that's going to take up more space in the landfill. I did mention that. Least wood is disposed of by burning, but it still produces. That's not true. Because none of the other one is disposed of by burning. I don't know. Most steel is disposed of by recycling and then a judgment. All right, so what you've got to do is you've got to get set to talk about everything in the table and then reach a judgment. I don't know if I did that particularly well, so apologies if not. Right then, again, we've got another evaluate question. It's the window frames question. No, I'll do question 2 first. The Earth's atmosphere is always changing. A little bit about atmosphere stuff. Gases in the Earth's early atmosphere cause changes on the Earth. Draw one line from each change. So it's not life cycle assessments, but it's good. Oceans formed. Gas that caused the change. The oceans are formed from water vapour. Sedimentary rocks were formed from carbon dioxide dissolving in the oceans and forming sediment. Okay. Calculation. Planting trees helps to reduce climate change because trees use carbon dioxide. Name the process in trees which uses carbon dioxide, photosynthesis. Figure 4 shows 2 ways of preventing used items going to landfill. So this is a life cycle assessment where you make something, you can use it for as long as it needs to be used, and then this suggests reusing it. So using it in a different way. Then you can chuck it away, and when you've disposed of it, you can recycle it and then make it again. So A is reuse, because you're using it again and again. And when you dispose of something and then turn it into new products, this is recycle. Okay. Pretty sure I got that right. Not obvious, that diagram, but where's my mark scheme? Sorry, everyone, making a mess of this. Reuse, recycle. I don't know where question G was, I missed it. Yeah, I don't know. Right then, what's your next question? Question number 3, life cycle assessments, and it's 3E. Window frames can be manufactured from wood or from plastic. The table below shows data from a life cycle assessment. So we've got some information here about the whole of the life cycle. A little bit of it for wooden window frames and a plastic window frame. Both window frames are the same size. Evaluate the sustainability. So we're looking at the environmental impact of wooden and plastic window frames. You should include environmental and economic, so that's cost factors. All right then. So what I would recommend is talk about each of these rows first and then make a judgment. All right, so I'm going to quickly go through that. Okay. Plastic window frames require more hydrocarbons to be used for production. Hydrocarbons are non-renewable. All right, whereas wood uses less hydrocarbons. So this is about raw materials, non-renewable, renewable. So I think that one's winning. Greenhouse gases release. So they both produce, I would say, a similar amount of greenhouse gases. Greenhouse gases are bad for the environment, they lead to climate change. Oxides of nitrogen and sulfur dioxide produced. So plastic production produces more oxides of nitrogen and sulfur dioxide, which can lead to acid rain. So that links to our last topic. Waste materials. Plastic produces more waste materials in kilograms, which is going to go to landfill, which is this common sort of idea that's coming up again and again. Total energy consumption. Plastic window frames take more energy to produce. Lifetime cost to customer would cost more over the lifetime to buy and maintain, because you're going to have to maintain them by painting them or whatever it might be. All right then. So I've talked a lot about environmental factors. The cost comes in at the bottom. Plastic window frames are also going to cost more to the manufacturer because they require more energy. Overall then, what's better? So the production of plastic window frames appears to be worse environmentally, because there's more waste produced in landfill, they produce more energy is required in their consumption, but they are cheaper for the customer. You've then got to evaluate. I think overall I would prefer, so me personally in this case, I would prefer wooden window frames, because even though they cost less, they have less environmental impact. That would be my judgment. You can make another judgment call if you like. All right, but from that information, that's what I'm going with. All right then, what do they say? Production of plastic uses more hydrocarbons. Production of plastic produces more greenhouse gases. So this is them just going through it. Production of plastic produces more sulfur dioxide, causing acid rain, and oxides of nitrogen, which cause acid rain and respiratory problems. Didn't mention that. I didn't mention that. Disposal of plastic products produce more waste in landfill. Burning plastic produces fumes which are toxic, so it causes respiratory problems. We're going to talk about burning plastic. I didn't, so I don't know why they burned them. Anyway, lifetime cost of plastic frames is less. Plastic frames have lower costs for maintaining, so they're easier to maintain. The total energy consumption for plastic frames is greater. What else can it say on here? And then a judgment. The judgment can be anything that you decide, as long as you say which one do you prefer and why. Which one do you think is more sustainable and why? All right then, another random maths question that you've got to do. So lots of sort of unit conversions. Next, producing copper from recycling waste copper reduces emissions of sulfur dioxide. Okay, why is reducing emissions of sulfur dioxide important? So this is from our diagram of the car. Sulfur dioxide causes acid rain and respiratory problems. All right. Copper is used to make coins. All right, again, another random calculation to do with percentages that you've got to be able to do. Life cycle assessments are used to assess the environmental impact of producing iron nails and glass bottles. There are 4 stages in a life cycle assessment. So it's this idea of like birth, which is going to be stage B, raw materials. Then you're going to make it and package it, B, C. Then you're going to use it, and then you're going to do that, B, C, D, A, B, C, D, A. Cool. You've got a graph. Industries use the Earth's natural copper resources to produce useful products. The figure below shows the world production of copper from 1900 to 2020. All right, describe the trend shown by the graph in the figure above. So, firstly, the world production of copper in billions of kilograms is increasing, or is increased from 1900 to 2020. So just an increase, but it's ramping up, isn't it? It's going up. So it's increasing by a bigger amount every year. All right? So it's increasing more every year. Let's just have a look at what it says there. Question 5. Question 5. Question 5. Production of copper is increasing at an increasing rate. So I didn't say it beautifully, but I did get the idea across. Suggest the reason for the trend in the figure above. We've got an increasing population. We'd have more and more electrical devices that require copper. I don't know what the actual answer is. Increasing population or demand, or we have more uses for copper. Cool, what was it like? Suggest the reason why the trend cannot be used to accurately predict the future world production of copper. So, basically what they're saying is, why can't you just assume that it's going to do that forever? Because somebody might. Well, you just never know, because we might find a material that does a better job than copper. I don't know, in around 2050 you might find something new. Copper might run out. I've already said in class that we're running out of high-grade ores. So any reason that you could think, basically, why can't you just go, oh, it's going to go up and up forever? All right. High-grade copper resources are now difficult to find. So this is going to be to do with phytomining and bioleaching from today's lesson. Phytomining is used to extract copper from low-grade ores. There are 5 stages. The stages are not in the correct order. All right then. So plants are burned, plants are harvested. All right. Plants absorb metal compounds, B. Plants are harvested, D. Let's just see if any of them start with BD. That one does. Where's the rest of the questions? Yeah, the other two start DB, so it's not them. It's BDCAE. Unless I'm being thick. I might be being thick. BDCAE, now I found it over there. There you go, I didn't need to do the whole question. If it starts BD, it was to BDCAE. Nice. Right. Two advantages of phytomining compared with traditional mining methods. Takes much less energy than traditional mining methods. Creates far less disruption to local communities. Okay, something like that. What else? Oh, disadvantages. I'm such a doofus. Disadvantages. It's slower than traditional mining methods. Really slow. You've got to wait for it to harvest. What else? Oh, you need loads of land. You're going to be using it. You're going to be burning a potential food crop as well. All right. Another percentage question. I hope you realise it now that there's loads of marks here for just doing percentage questions. You might be finding these really, really tricky. If that's the case, let me know next lesson. Okay, atmospheric pollution is emitted by cars. Some car emissions contain nitrogen dioxide. Describe how nitrogen dioxide is produced in the engine of the car. This is our diagram, wasn't it? Car in the middle. All right. Nitrogen and oxygen from the air react with each other in the heat and pressure of a car engine. Bosh, bosh. Emission from cars contain carbon dioxide, which is this one. Explain why carbon dioxide emissions during use and operation are not the total carbon footprint for a car. Refer to the stage of the life cycle assessment in the car in your answer. Explain why carbon dioxide emissions during use are not the total carbon footprint of a car. Okay, so when you make a car, when you extract the raw materials for the car, you're going to require lots of carbon dioxide will be produced because you require a lot of energy. So burning fuels to create energy. Let's just have a little look. I'm getting tired now. I've really got to go on. So, also if you dispose of your car, I suppose, as well. Right, question 6. Okay. Carbon dioxide is emitted when you process the raw materials. Carbon dioxide is emitted when you manufacture a car. Carbon dioxide is emitted at the end of the car's useful life. All right, when you either recycle it. Well, yeah, I suppose. There we go. So, I haven't explained this particular well, have I? These are so geography-ish, these questions. Right, why are life cycle assessments done? So, to assess how sustainable a process is or a material is, to assess environmental impact. Okay. Apparently, you couldn't say sustainable. To assess the environmental impact at the stages in the life of a product. You can't say sustainability. Ignore sustainability. Right, okay. To assess the environmental impact, maybe write that in your notes. Because that's what they want us to say, apparently. Compare two methods for disposal of biodegradable plastic bags. So, compare. That means you don't need a judgment. You don't need a judgment. You just got to compare. All right, so we go. This table below shows data for a life cycle assessment of the disposal of 10,000 biodegradable plastic bags. All right. Compare the two methods. So, in other words, should we burn plastic bags or should we send them to landfill? All right. When you burn plastic bags, you produce more carbon dioxide, which is a greenhouse gas, which leads to global warming. All right. So, I've compared them. So, when you send to landfill, or you can do when you send to landfill, less carbon dioxide is produced. When you send to landfill, you get more solid residue in kilograms. All right, so that will take up more space, I suppose. When you pour plastic bags in landfill, you produce more sulfur dioxide, which creates more acid rain and respiratory problems. So that's bad. Have I done it? Is that all I need to say? because that's sort of the end of what I've got to say. Question 7. Can't even find an answer scheme now. I am done. Here we go. So, scientifically relevant features are identified, and the way they are similar and different is made clear, and the magnitude of the similarity and difference is noted. Oh no. Oh, compare. Right. I've totally messed that question up, I think. The magnitude of similarity and difference is noted. Alright, so let's have a little look what it says. We'll learn this together, alright? So, indicative content. Burning your 10,000 bags produces 10 kilograms more of carbon dioxide. Alright, so, exclamation mark, compare. Use information from the table. Well, I sort of did, but it's very specific, isn't it? Putting 10,000 bags in landfill produces 0.02 more kilograms. So you've got to use the numbers, guys. And me, I'm talking to myself here as well. Mass of sulfur dioxide produced in kilograms. Yeah, 0.1 more sulfur dioxide. Or 50% more. So any of this sort of content, but look what they've done. To get the top mark, you need to use comparative numbers, either in kilograms or as a percentage or whatever it might be. You can still say all the stuff that I said, but putting numbers in makes it better. Alright, so I didn't completely mess it up, but I'm probably only going to score 2 out of 4. That was a shambles to go through, but it's still going to go on YouTube, because it's all about generating content. Not really. It's all about helping you with your exam. Hope that was useful. Right, see you later.